This is video 4.20 on the rotation of the factor pattern. Now with factor analysis in PCA, we often use those for dimension reduction, simplifying the data down to a smaller set of variables. But the data are more meaningful with the rotation or reconfiguration of the latent variables. So we are going to demonstrate that in this video. Now suppose, for example, that an organizational psychologist has created a management profiling instrument consisting of 12 questions. 6 are related to effectiveness in working with people, and we call that maintenance, as seen here on page 189 of your text. And we have 6 questions that relate to task effectiveness. And the data are factor analyzed, and the following factor pattern is obtained. And we see that here. So we have values of factor 1 on the left and factor 2 on the right. Now we can use the factor loadings as coordinates for plotting in the space of factor 1 and factor 2 and get a vector plot, which is shown on the next page for an unrotated factor pattern. We can see on this page that factor 1 here is located directly in the middle of the 2 bundles of vectors. This one down here being for maintenance, and the one up here being for the questions for task. Now, in an actual data set, this is the usual state of affairs when you initially factor analyze the solution. The first factor, or the first component, is always in the center of the collection of variables. Now, given that the 6 task variables all indicate positive performance, and given that the 6 maintenance variables also indicate positive performance, we see it here as there to the right, the first factor could be interpreted as overall positivity of the ratings. And then looking at factor 2 on the y-axis here, factor 2 in this configuration is a little more difficult to interpret because of the way that this displays on this plot, with the task variables all loading on the positive side and the maintenance variables all loading on the negative side down here. So conceivably we can interpret this as a kind of polar factor of task versus maintenance, but it's not very clear, and that probably doesn't have as much meaning. But if we look at this, a rotation of the pattern of approximately, if we go 40 degrees counterclockwise, so going this way about 40 degrees, we can make it easier to interpret. Where if we move down the page, we can look at the table that's there, and we see these are the new factor loadings that we get, and then even on the next page we have a plot. And looking at this plot, it becomes much easier to interpret, where you can see that factor 1 is definitely defined by maintenance. We see the clusters of the 6 maintenance variables or questions right there, and then factor 2 is defined by task. So essentially the goal of rotation is to seek factors that have mainly 0 or nearly 0 loadings within the center of clusters, with the center of clusters of variables. Let me say that again. So we want to have a cluster of loadings. We have a few high loadings that go with factor 2, and they're almost not correlated at all with factor 1, and the same with factor 1. We have factors that mainly have 0 or near 0 loadings with just a few high loadings, which places the factors as much as possible within the cluster of the center of variables. And this makes it much easier to interpret and easier to deal with. Now you're probably wondering how we knew that we should rotate it 40 degrees. Well, just by eyeballing the figure, it's figure 4.9 on page 190 in the text that we looked at before it was rotated, you can just take a protractor to that and measure how far it is from the center of these clusters to that factor. However, it's generally harder to do this with real data sets, and that's why we let software programs do this. So the software programs will go ahead and look at our matrix of factor loadings and determine how it needs to rotate it to give us the best results. So I mentioned before we rotated this 40 degrees counterclockwise. To avoid confusion, we should probably say rotate it clockwise, and in this case we subtract from 360. It's actually 41 degrees that we rotate it, so counterclockwise, so we'd be rotating it 319 degrees clockwise. So let's jump to Excel here, and I already have the unrotated factor loadings right here. And then in your text it talks about a transformation matrix. I like to call it a rotation matrix, and we call it V, which we obtain through this equation. We have cosine of alpha, where alpha is the clockwise, so in this case it would be 319. We have negative sine alpha, and cosine alpha again, which we get to be 0.755, 0.656, negative 0.656, and 0.755 again respectively. Now, in case you're wondering, there is a way to calculate this, these numbers here, using our counterclockwise rotation of 319 degrees. There's a way to do that in Excel. I'll show you how in case you're interested. We hit equals, and then you can do cosine. It returns the cosine of an angle. Do parenthesis, and then type in your degrees, so 319, and that's times, and we have to do pi, and do open parenthesis, and then close the parenthesis again, and divide that by 180. And this is necessary to get the proper value here. Hit enter and we get 0.755. To do it here for negative sine of alpha, we'll do a minus sign equals minus. Type in sine, which will return the sine of an angle. We've got 319 times, we have to do pi again, and divide that by 180. And I'll do the same thing here, just without the negative sign. And we can just copy and paste this one to get that value. Now, in case you're wondering why why did the times pi and then the open parenthesis, close parenthesis divided by 180, if we didn't do that, it would return a number in radians, but that's the formula to get it in degrees. So when the unrotated factor pattern is post-multiplied by this rotation matrix V, the result is indeed the rotated factor pattern, which we call F sub R, that has what we want. So what we'll do is matrix multiplication. MULT. Highlight our matrices. Control Shift Return. And that's the rotated factor pattern matrix that we saw in the text. Note that there are different kinds of rotations. One common one is called Varimax, that is often used in factor analysis, or PCA. And note that Varimax treats factors as orthogonal or uncorrelated, like our example here has. If you're interested in learning more about how to do this on SAS, SPSS, or Stata, you can go back to video 4.8 where I do a demonstration of how to do a factor analysis with a rotation. The rotations will be towards the end of those videos, but they will clearly demonstrate how to do a factor analysis in those statistical programs.